Let's dive into AI today. We're going to be talking about LoRA.
Oh, wow.
You might have heard of it.
Yeah.
All about making these really powerful AI models that we all know and love, like ChatGPT.
Right.
Making those way more efficient. Smaller, faster, cheaper.
Music to everyone's ears.
I know, right?
Yeah.
And our deep dive today is based on this paper, A Note on LoRA.
And what's really interesting about this paper is it has the potential to bring the power of AI to everyone, not just those with massive computing resources.
That is what has me so excited. But before we get ahead of ourselves, let's kind of set the stage. I mean, we're all impressed by what AI can do these days, right?
Oh, yeah?
From writing poems to coding websites. But have you ever stopped to think about what it actually takes to make that happen?
Yeah, behind the scenes, these AI models are crunching through mountains and mountains of data. And that requires a ton of computing power.
Yeah.
We're talking server farms that could power a small city.
Yeah.
And that costs money, not to mention energy.
It's like having a supercar that guzzles gas like there's no tomorrow. You might get a thrill out of driving it, but it's not exactly practical for everyday use. And that's where LoRA comes in, right?
Right. LoRA tackles this efficiency problem head on. Yep. Imagine trying to improve, let's say, a motorcycle. Okay, you try to rebuild the entire engine from scratch, which would be really time-consuming, complex.
Right.
Or you could add a sidecar that enhances its capabilities without altering the core design.
So instead of a complete overhaul, it's more like a targeted upgrade.
Right.
I like that.
Yeah, that's a great way to put it. So LoRA adds a set of adaptable parameters, that sidecar, to the main AI model.
Okay.
And these parameters, they learn to fine-tune the model for specific tasks without requiring you to retrain the entire thing.
Okay, let's unpack this sidecar analogy a bit further.
Right.
Why is this approach so groundbreaking? I mean, haven't researchers tried similar things before?
Yeah, they have. And, those attempts, they had their merits, things like adapters and prefix tuning.
Right.
But LoRA takes it a step further. The paper compares it to expanding a house horizontally instead of adding more floors.
Yeah.
So you're adding space and functionality.
Right.
But in a way that's more stable and efficient.
So it's not just about making things faster. It's about making them smarter and more resource aware.
Exactly. And that's where the real aha moment hits, at least for me. You see, a lot of people think LoRA is just about making AI training faster.
Okay.
It is, but that's not the main event.
Okay. You've got my attention. What's the bigger picture here?
It's about how we use these AI models, how we deploy them. LoRA makes it possible to run these powerful AI models on devices that are far less powerful than those giant server farms.
Now we're talking. You're saying that with LoRA, we could see complex AI running on our laptops, our phones, even things like smart appliances.
Are you getting it? LoRA makes AI deployment massively cheaper and more efficient, opening up a whole new world of possibilities. Imagine having access to personalized AI tutors, medical diagnosis tools, or even advanced creative assistants, all running locally on your devices.
That sounds like something straight out of a sci-fi novel. But before we get too far ahead of ourselves, can you explain how this deployment magic actually works? The paper mentions something about different methods for serving LoRA models.
Right. They talk about three main methods. You can merge the LoRA weights with the base model.
Okay.
Kind of like permanently installing that sidecar on your motorcycle.
Right.
Or you can keep them separate, but swappable, like having a set of different sidecars for different purposes.
Okay, I'm following so far. What's the third method?
That's where it gets really interesting. It's a technique they use in production that involves something called non-merged weights. Imagine a universal remote control that can switch between different sets of pre-programmed channels.
So the base model is like the universal remote, and each LoRA adaptation is like a different set of channel presets.
You got it. This method is incredibly efficient because you're essentially batching requests for different LoRA models together, all running on the same underlying hardware. Instead of needing a separate remote, or in this case, a whole separate model, for each variation, you can just swap out a small piece of code.
That's brilliant. It's like having one super efficient AI engine that can power a whole fleet of specialized models. This changes everything. But let's get down to brass tacks for a moment. The paper also talks about the importance of placement when it comes to LoRA. What does that mean exactly?
You're right. We can't just slap on these LoRA upgrades randomly and expect everything to work perfectly. Where you apply them within the AI model's architecture really matters. Think of it like fine-tuning those motorcycle upgrades. You wouldn't put a mud tire on a racing bike.
So how do you know where to install those LoRA upgrades for the best results? Is it a trial and error process, or is there some kind of roadmap?
Luckily, The researchers have developed some best practices. They recommend a progressive approach that starts with the attention layers of the model.
Hmm.
These layers are like the control center, deciding which parts of the input data the model should focus on.
So you're making those attention layers more adaptable with LoRA, allowing the model to learn more efficiently.
You got it.
Yeah.
If you need to go further, you can then move on to the embedding layers, which are responsible for representing words or concepts as numerical vectors.
So you're ensuring that the model understands and interprets the data in a more nuanced way.
Precisely. And finally, if necessary, you can apply LoRA to the fully connected layers, which are involved in the final stages of processing.
Okay, so we've got our attention, our understanding, and then our final output. I'm starting to see how each layer plays a crucial role. But the paper also mentions something called rank when it comes to these LoRA modules. What exactly does rank refer to in this context?
That's a great question. Think of rank as the processing power you're giving to each LoRA module. A lower rank means it's lighter and faster, while a higher rank gives it more flexibility to adapt and learn complex patterns. You can start with a lower rank and gradually increase it if you need the model to handle more challenging tasks.
It's like adjusting the horsepower of your motorcycle upgrade based on the terrain you're tackling.
Exactly. It's all about finding the right balance between efficiency and performance. But as with any new technology, there are always challenges and areas for improvement.
Right. There's no such thing as a free lunch, even in the world of AI. What are some of the hurdles that researchers are still working to overcome with LoRA? So are we talking speed bumps? Or are we talking like mountains here? What are some of the challenges that LoRA still faces?
Well, one of the interesting challenges is how to make LoRA play nicely with other techniques that are also aimed at making AI more efficient. For example, as we move towards even smaller and more portable AI models, we're starting to use techniques like quantization.
Quantization. Right. That rings a bell. Remind me what that's about again.
Essentially, it's like shrinking the numbers the model uses to do its calculations, making everything a bit more compact and faster. Think of it like using a smaller unit of measurement. You can fit more into the same space.
Okay, that makes sense. Smaller numbers, less storage space, faster processing. But you're saying this can sometimes clash with LoRA.
Exactly. It turns out that quantization can sometimes mess with LoRa's performance a bit. It's like trying to fine-tune that high-performance motorcycle engine. But some of your tools are just a tad too big for the job.
Ah, so you're introducing a bit of wiggle room, a bit of imprecision. And LoRA being so fine-tuned might not like that very much.
That's a great way to put it.
Yeah.
But don't worry, researchers are already on the case figuring out how to make LoRA more robust and less sensitive to the quirks of quantization. That's the exciting part about being on the cutting edge of AI. There's always something new to figure out.
I love that. Always learning, always adapting. And speaking of adapting, one thing that really struck me about this paper was how much emphasis it placed on the real-world implementation of LoRA. This isn't just some theoretical concept. It's being used right now to make AI more accessible.
Absolutely. And the way they're doing it is fascinating. They're essentially pooling resources and batching requests for different LoRA models together. It's like having a shared supercomputer that can switch between different tasks on the fly.
So instead of each AI model needing its own dedicated hardware, you can have hundreds, even thousands, all sharing the same resources thanks to LoRA.
Precisely. It's a complete paradigm shift in how we think about deploying AI. It's no longer this incredibly resource-intensive technology that's only accessible to the tech giants. LoRA is democratizing AI, making it possible for smaller companies, startups, even individuals to leverage its power.
No, that is incredibly exciting. As we wrap up this deep dive, is there one key takeaway you hope our listeners walk away with today?
I think the biggest takeaway is that LoRA isn't just an incremental improvement. It represents a fundamental shift in how we design, train, and deploy AI. It has the potential to make AI more powerful, more efficient, and most importantly, more accessible to everyone.
No more AI exclusivity. It's like going from the old days of needing a printing press to publish a book to suddenly having high-quality, affordable printing available to everyone. LoRA is opening doors and empowering a new generation of AI innovators.
Oh, I couldn't have said it better myself.
Yeah.
LoRA is a game changer, and I can't wait to see what the future holds as it continues to evolve.
And on that note, we'll wrap up this deep dive into the fascinating world of LoRA. We hope this has given you a glimpse into the incredible innovations happening in AI and the potential they hold for shaping our future. As always, thank you for joining us and keep those minds curious.